this video, Augustine and I will walk you through VMware Private AI on a consolidated, minimal VMware Cloud Foundation or VCF architecture. Achieving a full-scale VCF architecture across multiple regions is an evolutionary process, and many customers start small, with a foundational minimal footprint VCF deployment. A critical question we hear is, hey, if I'm starting small, can I still take advantage of the AI revolution with VMware Private AI? The answer is yes. You don't have to wait for a massive scale deployment to start harnessing the power of AI today. So let's dive in. First, what is VMware Private AI? VMware Private AI is an architectural approach that allows you to adopt Gen AI on premises, addressing many of the typical concerns of performance, flexibility, data privacy, and security. It's paramount that private data must be protected and controlled while being put to work in fine-tuning LLMs or in RAG applications. Deploying a full AI platform on private cloud infrastructure ensures that sensitive information and intellectual property are protected. In addition, Gen AI workloads can run alongside traditional workloads for cost effectiveness. Let's look deeper into the layers of VMware Private AI. There are three major elements here. So starting at the bottom, VCF provides the infrastructure layer, the perfect private cloud platform for all workloads, both AI and non-AI. On top of VCF, there are VCF Private AI services, which is a set of services that enables you to easily and securely deploy AI workloads in your VCF environment. I'll go more into the different services in the subsequent slides. Now, on top, we have NVIDIA AI Enterprise with all of its powerful capabilities for AI models, such as NIM microservices, NeMo Retriever, and NIM operators. I won't be going into the details of these, but you can certainly find more information about the NVIDIA services on their website. Let's dig deeper into what we're doing with NVIDIA. VMware Private AI Foundation with NVIDIA is a joint Gen AI platform by Broadcom and NVIDIA, delivering VCF infrastructure optimized with NVIDIA GPU technology. Within the vSphere client, there are orchestrated workflows to guide you through configuring this private AI infrastructure easily. In addition, with tight integration with VCF automation, you can deploy AI workstations or deep learning virtual machines and AI Kubernetes clusters right out of the box for data scientists and AI developers to use. Now, what about VCF Private AI services? These services streamline the deployment and management of Gen AI workloads, especially easing the implementation of RAG applications. This diagram shows a flow of an LLM model usage leveraging the VCF Private AI services. So first, starting all the way from the left, you can pull models from external sources wherever you want, like Hugging Face or NVIDIA GPU Cloud or NGC. Then using Deep Learning VM, you can push those models to a model store or Harbor as model registry. And from there, you can deploy model endpoints by using the model runtime service to give users a way to access these models. Now from there, below model runtime, you can see data indexing and retrieval services. You can use these to handle your private data in a vector database. And you can use all of these model endpoints and the indexed knowledge base to create a RAG application through the Agent Builder service. So a quick but important question, why VCF for AI workloads? When it comes to AI, a large amount of attention in the market is focused on models, ML algorithms, data collection, data analysis, fine-tuning, and more. These are all interesting topics and concerns. However, these activities cannot even start without the infrastructure. If you don't have a handle on the infrastructure, like the activities shown on the left side, right, such as monitoring and resource management, then your chances of being successful on the right side activities of data scientists and ML engineer, that chance would decrease significantly. And that's why VCF is crucial to this AI journey. VCF offers a comprehensive suite of software-defined services, enabling enterprises to build reliable and efficient cloud infrastructure with consistent operations across diverse environments. Now let's get to the fun stuff. Augustine's going to dive deep into the technical architecture of VCF and how VMware Private AI fits seamlessly into VCF.
At the center of VMware Cloud Foundation architecture is the construct of a workload domain. Workload domains are purpose-built units of private cloud capacity. They utilize standardized, repeatable infrastructure, allowing you to move away from provisioning and managing separate silos of custom infrastructure. Workload domains are configured with dedicated resources for compute, storage, networking, and security using inbuilt workflows. Once operational, admin staff can easily scale capacity and perform daily operations and lifecycle management of each domain as an independent unit. In order to understand the constructs of a VCF private cloud, you need to be familiar with VCF instances and VCF fleets. The first vSphere cluster of a VCF instance is configured as part of a management workload domain or management domain, and is used to host the management components. The SDC Manager appliance is deployed to the management domain. Additional workload domains can be created to scale deployment, which are each configured with their own vCenter server and a single or shared NSX instances. A VCF fleet can be comprised of one or more VCF instances and is managed by a single set of fleet-level management components. Fleet management components comprise of a single instance of VCF operations and a single instance of VCF automation, or VCFA. This can be used across all domains within a VCF instance and across one or more VCF instances. A VCF fleet can be deployed across a single region or dual region deployments. VCF Private Cloud is the highest level of management and consumption for the underlying software-defined data center resources. A VCF Private Cloud can contain one or more VCF fleets. Cloud Foundation caters to a mix of different deployment options to support a large variety of customer scenarios. Workload domains allow customers to separate their workloads from management components. Workload domains are deployed to separate hardware running their own separate vCenter server and NSX Manager instances, each configured with their own SSO instance, and can be comprised of multiple clusters. Once a domain is created, vCenter linking can later be configured from VCF operations or VCF ops. Workload domains can be deployed across one or more racks within an availability zone. Clusters can be configured as standard clusters within a single rack or across multiple racks when layer 3 networking is in place between the racks. Vcent stretch clusters can be configured across two sites for active-active availability. Availability zones are configured as fault domains that protect VMs in a vSphere cluster leveraging vSAN replication. vCent stretch clusters protect VMs against partial host failures within the clusters within a single data center and can be used to extend multiple nearby facilities or buildings. This is useful for performing planned maintenance without any downtime, automatic VM restart and recovery, and disaster avoidance. vSAN storage clusters, formerly known as vSAN Max, can also be used to provide highly scalable and flexible disaggregated storage for vSphere clusters, either as a primary storage or to augment traditional vSAN HCI clusters. vSAN compute clusters can also be configured to enable vSphere clusters, including non-vSAN clusters, to consume storage resources from a remote vSAN cluster. This slide illustrates our VCF consolidated architecture. This is a single VCF deployment, optimized for minimal footprint while delivering maximum AI capability. What makes this architecture powerful is how we've consolidated both management and GPU-accelerated AI workloads into a single workload domain, eliminating the need for traditional separation between management and compute domains, also allowing customers to start small and down the road start growing their AI deployment. Starting at the foundation, we have our VCF management stack, a VC Manager, vCenter, NSX Manager, VCF Ops, and VCFA. These are our control plane for the entire environment. One or multiple hosts could have GPUs and be configured with NVIDIA vGPU drivers, or basically NVIDIA BEVs on the ESXi host. These hosts support 3 GPU sharing modes: time-sliced vGPU, multi-instance GPU or MIG, and direct pass-through or PT. Here we can run pre-configured deep learning VMs with frameworks like PyTorch, TensorFlow, which are already optimized for GPU acceleration. These VMs can be provisioned in minutes through self-service catalogs in VCF automation. The supervisor cluster represents our VKS deployment. The supervisor control plane running as 3 highly available VMs provide a Kubernetes control plane directly on vSphere. This enables us to run containerized AI workloads through VKS clusters, deploy VMs via Kubernetes APIs using the VM service, and leverage supervisor services like Harbor, Private AI services, and others. The beauty here is that all of these workloads, whether VMs or containers, can access the same GPU resources. All of these workloads, all of these constructs are connected through NSX VPC, providing virtual private cloud isolation for multi-tenancy, overlaid networking using Geneve encapsulation, and tier 0, tier 1 gateway architecture for north-south traffic. This means that each AI project or team can have their own isolated network environment while sharing the same physical infrastructure. The key design considerations that make this work is first, we need to be very careful on the type of hardware that we select. We recommend at least 100 gig network connectivity to support vSAN ESA, to support high-speed network connectivity for our workloads, and also to allow advanced technologies such as RDMA over RoCE or Converged Ethernet for distributed training or distributed inference, or those workloads that require ultra-low latency or GPU to GPU communication. We need to be very careful on what we choose for hardware. That's a given. Now, one of the key considerations for having this collapsed or this consolidated VCF architecture is to have vSAN Express Storage Architecture, or ESA, as the storage foundation. It provides high throughput and low latency that AI workloads demand. We can use RAID 5 or RAID 6 erasure coding for efficiency of the usage of the storage. Now, there's other considerations that are part of this consolidated VCF architecture, such as anti-affinity rules for edges, such as do a proper sizing of the compute resources, meaning CPU and memory or RAM, to have room for growth, room for the management workloads such as VCF Ops, NSX Manager, and so on and so forth, and all the workloads that we want to run locally on that specific consolidated VCF architecture. Finally, here we can look at the different high-level components of private AI services and private AI running on top of VMware Cloud Foundation. This is the workload domain view. This is a single SON vSAN cluster of GPU-enabled servers. It shows the logical separation of the environment, including the supervisor cluster with the control plane and different namespaces. These namespaces host the key components for an AI application pipeline and different type of workloads that require GPU acceleration. The AI Kubernetes cluster for scalable deployment, and the core private AI services running in their own VKS cluster. This includes model runtime, data indexing and retrieval, agent builder, and so on. All of this interacts with our model store or hardware, which can be air-gapped for external sources if required. Thank you for watching.